Before we start really getting into triangles and studying them very in depth, I want to do what I'm loosely calling a detailed look at triangles. So we're going to start by, and I'm not going to go through this in a very organized fashion because I don't want you to think about things in a very rigid way. I want you to be fluid with your thinking. Classify each triangle by its angles and its sides. Well, let's talk about some possible names here, okay? A scalene triangle is all three sides are different, meaning all three sides are different scalars. Okay, scalars are just numbers like integers. Scalene. You also have isosceles, isosceles. Okay, that means that two are the same side. Two are the same length. Two sides. And then we have equilateral, which means that all three sides are equal. Okay, even though it's spelled E-Q-U-I, not E-Q-U-A. All right, so let's look at this. In this scenario right here, we have, and this, I should try to blow this up a little bit. Let me go to 2x. That's better. Okay. In this one, look what we have. We have all three sides are the same and all three angles are the same. That's obviously equilateral. And if it's equilateral, it's also equiangular, meaning that the angles are the same too. And so obviously if it's 60, 60, and 60, that's the only way to have an equiangular triangle, because there are 180 degrees in a triangle, and if they're all the same size, we just divide by 3 and we get 60 degrees each. 60, 120, 180. Okay? Looking over here, we have all three angles are different and all three sides are different. Since none of the sides are the same, we call it a scalene, S-C-A-L-E-N-E, scalene triangle. Okay? Looking down at this one now, we have two that are the same, and notice this. Notice that the angle across from them are the same. So this 26 is across from the 25. Do you see how I'm doing this here? This side that's 2.5, excuse me, not 25, 2.5, and it's across from that angle to 26 right there. And the same goes for this one. Okay? The same goes for this one right here. And we have this 26 across from this 2.5. Okay? Like that. So if you have, and of course, so if the two are the same, so this is isosceles. Okay? But if you have two sides that are the same, the angles across from those sides also have to be the same, because it's kind of like it's opening up the same amount. The side length and the angle measure are related. Okay? Here we have one, here we have one where nothing is the same, 11.2, 13.27. So this is a scalene. Okay? Here we have one with a 72 across from a 4.8 and a 72 across from a 4.8 right there. So this is isosceles. Isosceles. Here we have one, a 4.8 across from a 45 and a 4.8 across from a 45. So this is also isosceles. Okay? Alright, I'm going to skip that. No, I'm not. Okay. Now, looking at a diagram, let's look at this diagram. Here's two angles that are congruent because of the marks, and two sides that are congruent. So we can tell that this is an isosceles triangle. Okay? But on this diagram, nothing is marked, so what can we assume? We can assume all the sides are different and all the angles are different, so it's scalene. Okay? Here, what can we assume? Well, we can assume nothing. It does have a right angle, so it's a right triangle. It's a right triangle, okay? But we don't know anything else about the sides, okay? So, excuse me, not a right triangle. It's right scalene. It's a right triangle because it's... Where's my thing go? Here we go. It's a right triangle because it has a right angle, but notice that none of the sides are marked as the same, so it's also a scalene right triangle. Okay. This, none of the sides are marked, none of the angles are marked, so it's a scalene. And notice that, and we're going to go back and talk about the angles in just a minute here in more depth. Here I've got two angles and two sides are the same, so this is isosceles. Okay. Here I've got two angles that are the same and a right angle, so this is actually an isosceles right triangle. See how I did that? It's isosceles because of these two, but it's right because of that one. So it's isosceles and right. Now, I want to go back and mention some other words here. Okay? I want to go back and mention some other words here. If you have all angles, so let's just write this on here. So let me zoom out for this part. Okay. So if all angles are less than 180, it's called an acute triangle because all the angles are acute. Acute means less than 180. And then if one angle is greater than, or excuse me, not 180. Back up, I meant 90. Of course, they're all going to be less than 180 if there's only 180 degrees in the triangle. Less than 90, excuse me. If one angle is greater than 90, it's called an obtuse triangle. An obtuse triangle because it has one obtuse angle. Why do I say if one angle is greater than 90? What happens if two angles are greater than 90? Well, if two angles are greater than 90, then I'll have maybe, let's say, 100 plus 100 plus a third angle. Well, right there I'm at 200 degrees, and I only have 180 to deal with it. It's too much. So you can only have one bigger than 90, or you don't have a triangle. You'd end up with something that looks like this. You know what I mean? Like that could be 100 and that could be 100, but it's not a triangle. It's opened way too far. So if you have one that is over 100, or over 90, the other two have to be very small to keep it closing in. Okay? There's no way either of these could be greater than 90. Even if they were, you'd have something that looks like that. You know, you have a 90 there and a 90 there and a 100. It's just not going to work. Okay? All right. So looking back at this is equilateral and equiangular, but it's also acute, right? Because all of them are, let me zoom back in for this part. All of them are less than 90. This one, they're all less than 90, so it's scalene, isosceles, or, excuse me, let's move these words out of here because it's confusing me. Not that. This is scalene and acute. Okay? This is 90, so this is scalene right triangle. This is isosceles, but I have a 128 here. Notice that, 128. So it's isosceles obtuse. Here, it's isosceles, but all of them are less than 90, so this is isosceles acute. There's a right angle, so this is isosceles right. Here, this is scalene. Notice this one here is bigger than 90. It's bigger than 90. So this is a scalene obtuse. Okay. These are all less than 90, so this is a scalene acute. Okay. Scalene right, scalene, if we measure this, this looks a little bit less than 90, so I'll say that that's less than 90, maybe it's like 89 or 85 degrees, so this is scalene acute. This is obviously scalene obtuse, that's way bigger than 90. Scalene obtuse. And then this is isosceles right. Okay. Okay. Let's look at some of these. Acute isosceles, we've already seen what this would look like, you know, something like this, where you have those two are the same, slower, both, all the angles are less than 90. Right isosceles we saw up here, it's right and isosceles. But what about a right equilateral triangle? Well, if it's equilateral, all the angles have to be 60, so it can't have any right angles, 90-degree angles, because they all have to be 60. So this is not possible. That one's not possible. Okay. Similarly, a right obtuse triangle is also not possible, because right means 90, but obtuse means it has something bigger than 90, and so you can't have both. If this is greater than 90 and that's 90, right there, if I add those together, and I haven't even thought about the third angle that's in the picture, I'm over 180, so I don't have a triangle, so this is also not possible. Not possible. Okay. Of course, we know that triangles have an angle sum of 180 degrees. So in this triangle, if I have 65 and 57, then I just have to subtract 180 minus 65 minus 57, and I get 58. So I know that this has to be 58 degrees right there. Here, I have a right triangle with 40. Well, I know that 40 and whatever that is has to be 90, because then that 90 and this 90 gives me 180, so I know that has to be 50 degrees. Here, 130 and 20 is 150, and I know that if I have 180, then what's left is 30 degrees. So that would be 150 plus 30 is 180. Right here, I have 85 and 50, and then whatever is left has to fill in the gap up to 180. So if I subtract 85 and 50 from 180, I have 45 degrees. So that's got to be 45 degrees. Here, if I look at this, you might go, what the heck is this? Well, if this is 137, then that is the supplement of 137. So 181 minus 137 is 43, is that angle right there. So then 180 minus 102 minus 43 is going to give me this angle, which is what's left, and in this case that is 35 degrees, which means then if I'm trying to find the question mark there, the supplement of 35, right, the supplement of 35 is 145. So that's actually what I'm trying to find, because this is a linear pair right there. Don't forget about that. Okay, it's a linear pair right there. Same thing happens over here. If this is 35 by vertical angles, and 135 mean that I can figure out what that one is right there. It has to be 45, so then the supplement to that is 135. So that's the number I'm looking for, 135. See, I'm working through this? Okay, so 30 plus 20 is 50, right? And 180 minus 50 means this is 130. But by vertical angles, that means the question mark is 130 also. So question mark is 130. Okay? The supplement of 150, excuse me, good grief. The supplement of 155 is going to give me that angle, and the supplement of 155 is 25. So this is 25, but I have 60 and 25, which is 85, and 180 minus 85 gives me 95. So that one right there has to be 95, but then the supplement of that is 180 minus 95, which has to be 85. So the question mark equals 85 in this case. 85. Okay, even more complex examples, right? Even more complex examples. And you'll get some of these on your homework too. Okay, so what do we know? Good grief. Well, let's work through this. 60 and 65, I'm looking just at this triangle right here, right? If I already know the 60 and the 65, then the 180 that makes up the triangle minus this 125, do you see how that's 125, is going to give me 55 here. But then if all three of these, 1, 2, 3, that angle right there, all those three are supplementary, then 180 minus the 55 minus the 50 is going to give me 75 for that one. And then 75 plus 35, well, this is going to be the supplement of those two because we have to add up to 180. So 180 minus the 75 minus the 35 gives me 70 for that corner one, 70. I'm just going to do just do one more here. Okay. So right here, 45 is going to come into this by vertical angles with a 45. 45 and 60 is 105, which means this has to be 75 because it's the supplement of 180 minus 60 minus 45 gives me 75. But then this one is going to be whatever the supplement of these two added together is. So 180 minus the 75 minus the 68 gives me 37. So that's 37 right there. 37 and 100, this is going to be whatever's left over there. So 180 minus 137 gives me 43 left over here. But then this question mark is just the supplement of that one. So 180 minus 43 gives me 137 for my question mark right there. Okay? Good. You can also do these with algebra, and of course you'll see some of this on the homework. Doesn't change anything. Okay? All right. Isosceles and equilateral triangles. Let's look at this. If I have these two marked as congruent, and that is across from a 7, and this is across from x, these have to be the same. Okay, so x equals 7 because this angle is congruent to this angle, which means the sides across from them are also congruent. Look at this one. Here's another one. If this angle is congruent to that angle, and this angle is across from x, and this angle is across from 6, these have to be the same, which means that x has to equal 6.